Hello everyone, this is Solomon. I am here to explain you about the implementation of stack and queue ADT using linked list. ADT is nothing but abstract data type. So very shortly I want to tell you what is ADT. It's an abstract data type. It's a list of abstract data types. So this contains, let me show you clearly. So this contains get, insert, remove it, replace, size, is empty, is full. So these are the keywords in our data structures and algorithms. So insert, is full, we have to check the condition. These are conditions: getting, inserting, removing, all these things. And here we can see clearly node. So these are the positions. So if we take an queue, we can have all these things in the queue: header, position, rare, and everything. So this is a list. So this is a node. So in the node we have two parts. One will contain its address and one will contain the data. So this is a very short note about abstract data type. So let's directly go into the code. To compile my code, I'm using a PyCharm. This is a good compiler. So yeah, let me show. So this is my code. So I have declared a class called node. So we have constructed here. So init is a constructor. We are defining constructor self comma data. So data is our variable. So self dot data is equals to data. The data value will be stored here. So self dot next is equals to none. And we are creating a subclass in the superclass called node. So the subclass is called stack ds. So this is a stack. And next we are going for queue. Next we are going for queue. So in the stack we have three main important keywords, that is push, pop, and display. But whereas if we come into the case of queue, we have enqueue, dequeue, and display. So what are show. So this enqueue means inserting element and dequeue means deleting the element. Show is displaying. So if we consider in the case of stack, this is push, pop, and pop is to remove the element, push is to push the element into the stack, and display is to display the element. So as we know, this code we have discussed in our last videos. So how to replace the values and how to insert the values of the inserting data. So new node is equals to node data. So the data will be stored here. So we are checking a condition if a new node is none. So if the new node what we have entered is none, then it will print as stack is full. If there is no empty place in the stack, it will print stack is full. Else if there is any place, then the value will be stored in the new node. So self dot top is equals to new node. So this value will be stored here. So we are popping the element. As we know from the stack, first element will be in the last, and it will follow the rule as FIFO, LIFO. So last in, first out. So when we consider this pop, first element will first inserted element will be in the bottom, and the last inserted element will be popped out first. So pop self. So if self dot top is equals to none. So if it is none, if there is no elements in the stack, it will print as stack is empty. So if a stack contains any number or element, then it keep on popping out. So p is equals to p dot top. So the top element. So L, this is a variable. It's not matter whatever we keep here. So we can keep it as anything. So L is equals to p dot data. So self dot top is equals to self dot top next. So delete p. What is p? The first topmost element in the stack. So if we consider our stack like this, so if this is our stack, first element I have entered 5, next 1 and 2. So first I have entered an element 5. So first element will be popped as 2, then 1, then 5 will be popped out. In this way, we can see here first element. So the topmost element will be popped out from the stack. And if you consider the display, what are the elements present in the stack will be displayed. So if self.top is equals to none, if there is no elements, we cannot display anything, so directly it will print stack is empty. If there is any elements, so else print the elements are. So the elements are, you can keep an apostrophe. So the elements will come in this way. L is equal to self.top. So the topmost element will be printed here. First element will be taken, printed here. While L is not none. When L is not none, nothing but if there are elements in a stack, it will be not equals to none. So print L dot data and this is L dot next. So this will go to the next element. Again it will print. It will go to the next element. Again it's gonna print. So in this way it keep on printing until the elements are completely displayed. So if we come into the case of queue, similarly as we have discussed in the stack, the same thing, but the keywords are little different. So we are defining a constructor here, init and self equals to front and rear. We consider this. I wanna show you. So when we see here, so the NQ is nothing but adding an element and DQ is nothing but removing an element. So front is nothing but rear and yeah, exactly, we are using front and rear. So front is here, this is front and this is rear. Rear is nothing but the last what it comes, it's in rear here, and the front is the front element which we go in this way. So in the same way, when we take in this condition, enqueuing an element is nothing but inserting an element into a queue. So new node is equals to node data. So if new node is not none, in the same way the procedure, everything is same here. So we are checking a condition here. If self.front is equals to, is not none, then self.front is equals to new node, self.rear equal to new node. Because in this, when we insert an element, rear will be incremented. When we dequeue an element, front will be incremented in a queue. So in this way this goes on. So else self.rear is equal rear dot next equal to new node and self.rear equal to new node. So new node, the value will be stored in the rear. In the same way, dequeuing the element, so first element which is inserted, it will be removed first. This is called FIFO. So queue follows the FIFO procedure. So first element will be removed first. So if self.front is equals to not none, if it is not none, front is not none, if there are no elements, then it will print queue is empty. But if there are any elements, if self.rear double equal to, that is nothing but we are checking a condition, this is equals to front is equals to rear. So if the element is in the middle, this condition works. So p is equals to self.front equals to none, rear self.rear is equals to none, that is none is nothing but null, its value is 0. So x equals to p dot data, we are deleting p and returning the value of x. So the remaining, what all the values remaining in the queue will be printed. Else it will go to the else part. P equals to self.front and self.front equal to self.front into next, it will go to the next one. In this way again it will remove an element. So show is nothing but displaying the element. This will carry out in the same way. If there are no elements, it will print as queue is empty. If there are some elements, the elements in the queue are it will take the value p is nothing but the element and it will display here and it will check the condition while p is not none. If it is not none, if there are elements, p dot data equal to the values what are present in the queue. So we are defining in the same way, we are checking an condition. If a user enters 1, if he want to push or pop or display the element separately. Individually we are gonna discuss this everything. So first we are taking a stack. So first, if I want to push an element, he need to press 1, pop for 2, display 3, and exit for 4. So this values the value entered by the user will store in ch, nothing but character. As this is a variable, it can be abc, whatever we want. So we are checking condition. If ch is equals to 1, s dot push int init, we are taking an input here and enter the data. So he will enter the data. It is calling the function here, and it will go and perform the activity there. So s equals to stack ds. So else, if he enters the value to print pop, so he will pop out the elements. So if the character is 3, it will display all the values which is present in the stack. So in the same way we are going for q. All this will check the condition, the value entered by the user, and it will perform the activity. Or while print 1 for first this thing will be printed for the user. So first he want to enter the elements into queue or stack. So first this will be displayed on the screen. So he need to choose it. He need to enter into stack or queue. So when he enters stack, it will go to the stack part and it will implement here, and when he exit from here, it will come to again while part. So if he enters 2, it will go into the queue part and it will execute. Rest of this, it will come out of the program and break the program. So let's see how this code is gonna run and check the exact output, how it's gonna give us. So I'm running the code here. Stop and return. Yeah. So yeah, we can see here it's asking for enter the elements in linked list, linked stack or linked queue. So I want to first, I'll go with stack. So I want to push first element, so I'll go with 20. Again I want to enter an element, insert an element, I'll go with 30. Again I want to insert an element, 40. Again I want to insert element, 50. So let display. So we can see here 50, 40, 30, 20. So first what we have element entered 20 and 30, 40, 50. Let's pop the element and what's the output? Let's see. Yeah, we have popped one element. So 50 is popped out of the stack. So let's display the values what we are going to. So 40, 30, 20 are remaining. So first entered element is not at all popped out. So the last element, LIFO, last in first out. Last element inserted will be popped out first. So let's come out of this and we have came out. We can see here, enter your choice. So linked stack or linked queue. Now we'll go with queue. So we can see the names also completely different. It's a NQ, DQ, display. So first we'll go with NQing an elements. So let's go with the 20. I want to again NQ. 30. Again I want to NQ. 40. Again I want to NQ. That's 50. Let me display. So 3 is for display. You can see 20, 30, 40, 50. So in queue implementation, if we pop or DQ the element, first element should be removed 20 because first inserted element is 20 and the last inserted element is 50. So let's DQ and let's check what's going to happen. So we have DQ'd. So 20 is DQ'd from the stack. Let's display what it's gonna display. It's nothing but 3. We can see here the elements are 30, 40, 50. Exactly what I said the program has run. So let's exit from this. Again we can go to this and perform. So let me come out of the program completely. So the process is finished. In this way, the queue and stack implementation of ADT using linked list. So I hope you all understood. That's all in this video. Thank you.